So do 3 problems on the homework or similar to the homework, 76 first. The question asked find this complex number to the third and results in standard form. So first we're going to convert into polar or trigonometric form, and then after taking it to the third power we will convert back. So interestingly, we have a 4 out front, so everything we're going to want to do here in terms of first converting and take the complex number and taking it to the third, we're going to do all of that and then multiply it by 4 at the end. So just dealing with what's inside the parentheses first, I need to find r, and so r will be the square root of the sum of the squares of our a and b, which would be 1 plus 3 root 4, which equals 2. So r equals 2. To find our theta, we can do tan inverse. Tan inverse of the b over a. Doesn't really matter if we do the negative or not. We're just finding the reference angle. And I like writing it like that, theta sub r. Whenever we have y over x where x is 1, our y is root 3. So that would be a 60 degree or pi over 3. I'm going to go 60 degree. I'm going to do it in degrees. 60 degree reference angle, and I got to figure out what quadrant that's in. So if we look 1 minus root 3, if we go 1 to the right and then down for root 3, that puts us in the 4th quadrant. So if we have a 60 degree reference angle in the 4th quadrant, that would be a 300 degree actual rotation. So our complex number now is 2 cis 300, and we are taking that to the third power, and we also have a 4 out front. So when we keep the 4 out front, 2 to the third power would give us 8, and then cis, that would be 900 because we multiply 3 times 300, and I'm going to coterminal angle that down by subtracting 360 from 900. I do that twice, which is 720, gives us 180. So now we got to work on simplifying this. I can multiply the 4 in, so I'm going to multiply the 4 in, and I'm also going to write this in standard form, cosine 180 plus I sine 180. And then we're just going to do our calculation. So cosine 180 is negative 1. So if I do 32 times negative 1, that would give us negative 32. Sine 180 is 0, so that would go to 0. 0 times 32 is a 0, so our answer is negative 32. So 92 is finding the 5th root of 32 cis 5 pi over 6. So we need to do, and let's see, they want the final answer in standard form. So maybe I won't go and convert all of them to standard form, but we'll see how this goes. So there's 5 roots. So we start out at z sub 0, that's our k equals z sub 0. And then we go up to z sub 4, 1 less than n. So we have a total of 5 roots. So z sub 0, if we're taking the 5th root, and note, I'll write this or explicitly say you're taking the 5th root. So whatever we do to the complex number, that's what we do to z, or to r. So if we take the 5th root 32, that would be 2. And then cis, what we do is we take the first time, we take the initial angle and divide by n, which is 5 in this case because it's 5th root. So we're taking that, and I'm just going to write as multiplying by a 5th. The 5's obviously cancel, so that ends up giving us, for our first one, 2 cis, the 5's cancel, leaves us with pi over 6. If I expand that out to get it into standard form, or a plus bi form, that would be cosine pi over 6 plus I sine pi over 6. So note we have here, like I said, I'm not going to do this for all of them. Hopefully you get the idea of converting after you get the 5th root, in this case the z sub 0. So cosine pi over 6 is root 3 over 2, so if I multiply 2 times root 3 over 2. The 2's cancel, and we're left with root 3. Sine pi over 6 for right here is equal to a half. If I distribute it in a half times 2 is obviously 1. So I have 1i, or just I. Now, just a quick reminder, at least for my students, the way I describe it is that for these problems, you need to make 3 calculations to find all of your roots. 1, you have to find the root of r, which we did, which is 2. The second is our first angle, which is our initial angle, 5 pi over 6 divided by n, and that gives you, in this case, pi over 6. And then the third calculation is taking 360, or 2 pi, and dividing by n, and that's how much you're going up each time. So since we're in radians, we're going to take 2 pi and divide by 5, because that's our root, and that's how much we are increasing by for each k value. So our next one right here is going to be 2 cis, and we're going to take our z sub 0 angle, which is pi over 6, and we are going to add 2 pi over 5 to it. Now it's kind of a drag because it doesn't have like denominators. So what's going to happen is after we get this one, then we will be in probably much better shape in terms of efficiently calculating the other z's, z sub 2, and so on after we get this one. So I'm going to get like denominators. So in order to get like denominators, I'm going to multiply this by 5 over 5. I'm going to multiply this one by 6 over 6. And when I multiply by 5 over 5, I get 5 pi over 30 plus 12 pi over 30, which then results to 2 cis 17 pi over 30. So, and then of course you would get that into standard form. 17 pi over 30 is obviously a nasty rotation, so you could just estimate that and you would get decimals for your answer in terms of getting into a plus bi form. So what's nice about this now is that our last angle was 17 pi over 30, and we're going to add that to what we found before, which are increasing, which in terms of over 30, that's the 2 pi over 5. Over 30, we are adding 12 pi over 30. So now once we have it once, we can continue adding that same amount over and over again. Makes it a little easier. So now we have 2 cis 29 pi over 30. Sorry about the sloppiness there, but hopefully you see that. 2 for the 29. When we go to z sub 3, we're going to continue in the same fashion. 2 cis, take our last angle of 29 pi over 30, and add 12 pi over 30 to it. And that would give us 2 cis 41 pi over 30. And again, converting these into standard form is going to be nasty. You just use the decimal that the calculator would give you. Just make sure you're in radian mode. And the last one would be 41 pi over 30 plus 12 pi over 30 again, which then gives you 2 cis 53 pi over 30. And then not 100% check, but a way that you could see is if I added 12 again, that would put us at 65 pi over 30, which is over 2 pi, which then indicates that we would be done. But we also know that we should be done because we have 5 roots. So for 98, they give it to us in standard form. They ask for the 4th root of I. So first, we didn't have to do it in the last one, but we do have to do it in this one. And that's first convert it into trigonometric or polar form. First off, as a standard form is 0 plus I. Now, given that's a quadrantal, right? So the a is 0 and the I is 1, I could just graph that I like doing that with quadrantals and saying, okay, well, if I graph that point, that's 0 plus I need to know what my r and theta is. Well, if I'm going up 1, my r is equal to 1. That would just be the same as 0 squared plus 1 squared rooted would give us 1. Furthermore, that's a rotation of pi over 2. So our theta is pi over 2. So that gives us our complex number is 1 cis pi over 2. If we want to call that W, it's nice to call it something else other than Z, because it's kind of nice to have our roots in terms of Z. And then we are fourth rooting that. We're fourth rooting W. And our first root is going to be Z sub 0. That's a Z, not a 2. So fourth root of 1 is 1 cis. And then we're going to take pi over 4, or excuse me, pi over 2 and divide it by 4. And that would just be 2 times 4 in the denominator would give us pi over 8. So that would be our first one. And then you'd convert that into standard form just like we did in the last problem. It's not going to be a nice, neat number. On the test, I believe if you do have to convert, on most of them, they're just going to be nice, neat unit circle rotations. If not, you simply use decimals. So now we need to figure out how much we are going up by, and that's by doing 360 over n or 2 pi over n. So 2 pi, we could put a k there if we want to indicate how much we're increasing by. And that would be pi over 2k. You don't have to write the k, but hopefully that helps. So 1 cis, we start off with our pi over 8, and we are going to add pi over 2 to that. So we're going to have to get like denominator, so I'll just do that right here. I'm going to multiply the second one by 4 over 4, which will then give us 4 pi over 8. So our next one's going to be 1 cis 1 pi over 8 plus 4 pi over 8 gives us 5 pi over 8. And then we will continue doing the same thing. 1 cis, last one was 5 pi over 8. Add 4 pi over 8 to it. And that will give us 1 cis 9 pi over 8. And then our last one is e sub 3 equals 1 cis 9 pi over 8 plus 4 pi over 8 gives us 1 cis 13 pi over 8.